So what we want to look at in this theorem is the idea that we've got two chords and what happens when we get equal chords here. So you've noticed our chords C, D and E, F here. They're going to subtend these two angles here. So at the moment they're not equal. So what I'm going to try and do is have a look at the angles here. So I'll just measure the angles. So get it to come up and see if we can get them coming up nicely for us. So that one's no, we're not going the right way there. So if we go the other way. So we're measuring these angles here and getting them to come up. So measure that one. Didn't. Let's try it again. It's not measuring that angle for us. Let's go back and measure the angle. So let's pick our points here. That's starting to measure the angle for us. So our angles coming up there, 75, and this one here, we get a little bit, so we can get a little bit nicer. That's 80 degrees. So they're close, but they're not equal. But if you notice here, our chords aren't equal. So what we're going to try and do is get our chords to be equal. So it's not as easy as it seems because it's measuring. Oh, we got it there. So it comes up reasonably nicely. Now, realize that we're measuring to the nearest hundredth, and actually this was measuring probably even more accurately, but doesn't show up. But if you have a look at what's happening to our angles, so once we got our sides, our chords being equal there, we got the angles starting to measure up. So if I go to change the size of them, both of them there, so 4.7, if I move this one, we'll see if I can get 4.79 there. We're getting close. We start to notice our angles start to be the same. So equal, once our chords are equal, we get the angles at the center being equal as well. And vice versa, if I get the angles being equal there, then the chords will actually be the same. And that would actually be the same for the arcs there. The arcs would be this equal as well if the angles at the center are equal. So that's our first theorem. That's what it looks like in practice. How do we prove that? Well, we look at our proof here. So to prove this first one is equal chords subtend equal angles at the center. What we're going to do, we're going to know that our chords are equal. Now we do know a few other things. We know that these sides are going to be equal because they're all radii of the circle. So what we've done here is basically shown that if that chord's equal and we've got those two sides equal, obviously, because they're radii, then we're able to prove that the two triangles there are congruent. Because you've got equal radii for those sides, you've got the two chords are equal because we were told that. And therefore, by congruent triangles, we get all three sides equal, which means that the two angles inside there, because they're in the corresponding positions between the two equal sides, two equal radii, they must be equal as well because they're corresponding angles in congruent triangles. So that basically means that once we've got equal chords, the angles that subtend at the center are going to be equal. And there's our first theorem. The converse of this theorem. Now the word converse means basically the reverse of this theorem. So the idea here is that if we start with the angles being equal, then the chords must be the same. Again, how do we prove that? Well, we're told that these two angles are equal. And again, we know that we've got radii of the circle that must be equal. Those two sides must be equal. Which again, we can prove that these two are congruent because we've got two sides and the included angle are equal. So we're given those sides, we've got the radii, which by side angle side, the two triangles are congruent, which means that the other sides must be equal there. So that's what the converse means. It means inverse or opposite. So it's we can always use the converse of theorems. Once we know that chords subtend equal angles, then equal angles will subtend the same chord, so they must be equal there. So there's the proof. Should be able to prove these. It's not a hard proof because all we're doing is using congruent triangles. So check the proofs carefully. Be able to reproduce it. Be able to use that theorem anytime we are doing a problem, and be able to say, well, we know that the case is that equal angles will give us equal chords, or vice versa, equal chords will give us equal angles at the center.